Welcome back. Okay, let's dive right into this. Today, we're bringing you a high-signal, zero-fluff explainer focused on what is easily one of the most critical aspects of digital printing: direct-to-film, or DTF, white ink management. Look, if you're running a print shop, you already know the golden rule, right? Time is money, and predictability? Well, predictability is profit. We're going to break down the absolutely strict operational protocols you need to keep your machine printing profitably. We're starting right at the root cause of the most common hardware failures and taking it all the way through to your daily operational reality. And here is the absolute truth of DTF production. White ink is the foundation of literally every successful transfer. I mean, it's quite literally the base layer that makes your colors pop and your transfers actually bind to the garment. But, and this is a massive but here, it is also the system's greatest mechanical vulnerability. Mastering how you manage this specific ink is, well, it's absolutely non-negotiable. If you get this wrong, the rest of your workflow honestly doesn't matter. You aren't just risking a bad print, you are risking catastrophic hardware failure. So, Section 1, the titanium dioxide problem. Let's move forward and see how this builds, because before we can even talk about maintenance routines, we have to understand exactly what we're fighting against at a microscopic chemical level. The core culprit here is titanium dioxide. Fun fact, this is the exact same heavy pigment used to make sunscreen and toothpaste intensely white. So why do we use it in printing? Well, because it achieves that brilliant, extreme opacity that high-quality DTF transfers absolutely demand. But that exact characteristic, that intense, heavy density, is exactly what makes the pigment such a headache. If the ink is left stagnant for even a short period of time, these heavy titanium dioxide particles rapidly separate from their liquid carrier fluids. Basically, gravity takes over, and they just drop like a rock. And when that separation happens, there's this brutal, almost perfectly precise four-step chain reaction to disaster. Step 1, pigment separation begins the absolute second the ink stops moving. Step 2, those heavy pigments start settling. They settle at the bottom of your ink lines, they pool up in your dampers, and worst of all, they sink right into the printhead itself. Step 3, this settling creates microscopic blockages. Now, in the real world, on your shop floor, you'll see this as deflected nozzles and banding on your prints. And finally, Step 4, if you leave those blockages unaddressed, they solidify, leading straight to permanent printhead failure. Boom. A completely ruined printhead simply because the ink sat still. Which brings us to Section 2, verifying automated systems. Now, manufacturers actually know all about this chemical reality. So let's look at the mechanical safeguards built into commercial DTF systems, and more importantly, the operational danger of trusting those systems a little too much. Look, commercial DTF printers aren't totally defenseless here. They employ two primary mechanical safeguards against all this pigment settling. First up, the main white ink tank features a motorized agitator. This literally physically stirs the bulk ink to keep it properly mixed. Second, there's a continuous circulation pump system that constantly moves the white ink through the lines and cycles it right back to the tank. We get it, these hardware capabilities are fantastic, and they definitely do a ton of the heavy lifting to keep that titanium dioxide suspended. And this brilliantly illustrates the trap that so many print shop operators fall into. On one hand, you've got automated circulation. That's the mechanical design theory. The machine is supposed to keep the ink moving. But on the other hand, you have physical inspection, which is your actual operational reality. Because, let's be real, motors burn out, tubes get kinked, pumps lose pressure. The theory says the machine is completely taking care of itself, but the reality demands daily visual verification by an operator to ensure those systems are actually doing what they're supposed to be doing. So the crucial point is this: relying blindly on automated circulation without physical inspection is a guaranteed path to hardware failure. Avoiding physical checks is honestly a catastrophic error. You just absolutely cannot assume the agitator is spinning just because the machine is plugged in and powered on. You have to look, you have to listen, and you have to verify every single day, no exceptions. All right, moving on to Section 3, capping station protocols. We're shifting focus from the ink lines and circulation pumps to the printhead's resting environment, the highly critical capping station. Let's clearly define exactly what this is. The capping station is the mechanism that creates a pristine, airtight vacuum seal right against the printhead. Whenever your printhead isn't actively zipping across the platen and laying down ink, it has to rest here. Why? Well, because any air exposure will cause that highly pigmented white ink to dry and literally crust over those microscopic nozzles. That airtight vacuum seal is absolutely paramount for printhead survival when the machine is idle. If that seal is compromised at all, air gets in and your printhead dies. It really is that simple. Because that seal is so vital, you have to meticulously maintain the environment around it. So, here is your non-negotiable daily defense checklist. First up, clean the wiper blade. This little blade swipes across the printhead to keep it clean, but if the blade itself is caked in dried white ink, yeah, it's just going to smear debris straight into the nozzles. Not good. Second, wipe the capping station edges with a specialized cleaning solution. A perfectly clean edge is what guarantees that perfect airtight vacuum seal we just talked about. And finally, ensure the spittoon is entirely clear. You want waste ink to properly drain without pooling up and creating this awful sludgy mess. These specific physical steps, guys, they are literally the armor protecting your hardware. Let's pivot slightly for Section 4, driving uptime and consistency. We've talked a lot about the chemistry, the hardware, the daily chores. Now let's shift and look at the direct, overarching impact all this has on your print shop's bottom line. Now, what's really interesting about this concept is how it completely reframes everything we just discussed. Reactive maintenance destroys uptime. Seriously, if you're only cleaning your capping station or checking your agitators after you've already noticed banding on a print, you've already lost. At that point, you're throwing away ruined garments, you're wasting super expensive PET film, and your entire production schedule has basically just ground to a halt. Proactive maintenance is not just a chore, it is a primary driver of your operational profit. By standardizing these proactive white ink management protocols, you actually transform your business. First, it drastically reduces touch points because your operators aren't constantly stopping what they're doing to troubleshoot random clogs. That naturally leads to the next point. It significantly decreases equipment downtime. Plus, by creating a really rigid, standardized routine, it simplifies your execution and makes operator training infinitely easier for new hires. Ultimately, standardizing this proactive approach guarantees improved consistency across your entire production schedule. And honestly, that is exactly how print shops successfully scale. I want to leave you with this final kind of provocative question. Take a hard look at your own shop floor. Are your daily physical checks, verifying the agitation, checking the circulation, cleaning that capping station, are they a rigid, unbreakable habit? Or are you simply trusting the machine to do the work and risking catastrophic printhead failure? Because remember, the titanium dioxide absolutely does not care about your production schedule. It's going to settle if you let it. Take control of your daily routines, and I promise you'll take control of your profitability. Thanks for joining me on this explainer, and keep printing smart.